It's my extreme pleasure to introduce Jamie Duncan to give you a session around containers don't matter, long live containers.
Containers are dead.
What?
I changed it.
Containers are dead. That's not what this says. Is that brain approved?
No.
No. All right, anyway, enjoy.
All right, so thanks for hanging out. Hopefully lunches. If you've got a cookie, I highly recommend them. The ones dipped in chocolate. Jesus Christ. Oh my God, man. So I wrote an abstract about 3 months ago for our marketing team. They said, we should do something around containers, but not your normal container talk where I sit down and explain what containers are and we talk about namespaces and stuff, and then everyone falls asleep. So I said, at 3 a.m., I wrote this little abstract about, containers exploded and containers are commodities and the thing you have to worry about something else. And unfortunately, the marketing team liked it, so that's what they went with. And then I had to sit down a couple weeks ago and actually decide what to talk about. And any talk I give, I like to base it on what I'm talking to my customers about over that given time. So if I do a talk at Red Hat Summit every year, it's what I've talked to my customers about the year previously. And so today, I've been trying to figure out, how do I talk about this kind of containers are dead, long-lived containers idea with what I've been talking about with my customers. And I decided I couldn't do it without insulting almost every person I've talked to in the government's container strategy. So I said, well, I'm just going to have to insult everyone's container strategy. Because to be quite honest, I'm a little tired of it. We're focusing on the wrong thing. And we're focusing on the wrong thing. I don't know why anymore. And I know that containers are weird. I know containers feel funny. But we have to focus on the right part of the container ecosystem if we're going to succeed with them. So for the next 27 minutes, plus or minus, that's what I've talked about. I think I have 9 slides, including the About Me slide, which is next. So a little bit about me, if you don't know. A lot of familiar faces in the room. I've talked to a lot of you folks before. Been at Red Hat 6.5 plus years, so closing in on 7 years. The entire time I've been working with federal government customers. So I know nothing except how to work with Red Hat, how to work with government customers at Red Hat. That's my entire experience set. So I've worked with every major government agency there is. 3 letters, 4 letters, 7 letters, random names I don't remember. This is my daughter, Elizabeth. She is the cutest thing ever. She's my good luck charm. I stick her on every talk. She's got 2 big swords over her shoulders. Just out of scene, there is a crying 3-year-old who just got beat up with a sword and had his sword taken. She's about 18 months old here. I don't know what I've got on my hands, but she's really, really cute. The 3-year-old belongs to Chris Reynolds, who's running the Ansible workshop upstairs. She beat up his 3-year-old boy with his own sword. So we're full tilt boogie in my house. And then, again, shameless plug, we have an OpenShift book out. So kind of coming at the reason, I stick this in everywhere because, well, I get paid $2 a book. But more importantly, I am a huge fan of containers. I've been talking about containers since before we called them containers. So I love the technology. And someone that's been using them for 4+ years, since before Docker was ever called Cloud. Whatever they were called, I'm telling you, we're doing it wrong. And we're especially doing it wrong in the government space. We're focused on the wrong part of the equation. And that's what I want to talk a little bit about today. Not to berate everyone, but kind of to berate everyone. And anytime I'm in front of a crowd, I want to hear your feedback. So if y'all think, God, Jamie, you're an idiot, and here's why. I mean, we're recording this, so feel free to chime in. Let's have a discussion. I mean, we've got 25 minutes left. So why the whole containers are dead thing? It's not true, obviously. Containers aren't going anywhere. Containers are an evolution in how we isolate processes. And it's kind of crazy when you look at all the marketing around containers. We talk about, if I ask Tarek Islam sitting here, he's an incredible developer, he works at Google, or Michelle Davis, who's sitting beside him. If you ask one of them what a container is, they start talking about this immutable way to transport an application from one place to another. They're looking at it from a very developer-centric point of view. I'm an old ops guy. I talk about it lets me run more in my data center. It's an evolution of how I isolate a process. And we'll get more into what that means here in just a second. So these evolutionary jumps, why I'm saying containers are dead is evolution is boring. I don't know if anyone's ever read The Origin of Species, but it's not what you listen to sitting on traffic in 95. Not real great reading. Evolution does not stay trendy very long. So the idea of the container, as a container becomes more and more just a part of our fabric, a part of how we do IT, and that's going to stay true for the next 5, 7, 8 years, the sexiness of containers goes away. So all of that craziness, of all of us focusing on how do I write a better Docker file, Docker files aren't important anymore. Docker files haven't been important for a while. So Tim become the fabric of how we do. That essential fabric doesn't stay trendy very long. I just remembered I have the same thing on my screen over here. What do I mean by that evolution of process isolation? And this comes out of my talk from Summit a few weeks ago. We have kind of two axes here. We're talking about as something goes left to right, it gets more abstracted and more automatable. And we all can make that leap, right? The more abstracted something is, the easier I can automate it. It's really hard to automate plugging a wire into a server. It's really even harder to automate racking a server. But it's real easy to automate creating a VM. VM is more abstracted, VM is easier to automate. So we can all make that leap. And on the left, on the bottom scale, we have size and power consumed. A mainframe takes more power than a pizza box. A pizza box takes more power than a VM. So we can all make that leap as well. And we've been isolating processes since we've had processes to isolate. ENIAC, you could run one process at a time. You had to go flip switches. Like the word bug was a bug in one of these giant computers. You had to literally go flip the switches to put something in or out of memory, to write a 1 or a 0. No isolation whatsoever. You were talking physically to the process. Well, then we got mainframes. And then when I talk about containers a lot, I talk about Unix time sharing, the UTS namespace. It comes from back in this day. Mainframes is when we figured out more than one person could log into a computer at the same time. It was time sharing. We shared time on a server, way back when. So we were able to isolate more. We still weren't very abstracted at this point because mainframes in the 70s were the size of this room. But we're getting there. You know, at least I'm not flipping dip switches to make memory work. Then we got to the stuff that most of us recognize as IT. Although raise your hand if you still have a mainframe you have to deal with. Yeah, that. Like this poor gentleman's hand went up like, oh my God, yes. I'm so sorry. Like there's some pain in that hand raise. Excuse me. But then we have the client server model. Pizza boxes, x86 servers. The client server revolution that took off, what, 20 plus years ago now? That's what we all recognize as IT. And you started to get abstractable here. There are robots that could rack and stack servers for us. Really expensive, and I don't know anyone uses them anymore, but you could make it. We started trying to do that here. And obviously, you know, I think ENIAC had its own power station. Pizza boxes typically run off 110 or 220. So we're certainly consuming less power and we're taking up less size. Then we got to VMs, which is where most of us are today. VMs are really abstracted. It's a completely virtualized server. We have a virtual CPU, we have virtual hardware, we attach it, we run a kernel inside our virtualized hardware, we do all of those things. Very abstracted, very automatable, consumes an amazingly hard to measure amount of power. Can anyone measure how much a VM takes in their infrastructure? I don't know of anyone that's come up with that one yet, and we're how many years into the technology? I would love for someone to figure that out. How many watts does a VM take? But, so we have virtual machines, and then at the end, we have containers. All the way going left to right, we're getting smaller. We go from having the memory being a physical switch, to the memory being in a mainframe, to the memory being in a server, to the memory being virtualized multiple times in a server, to the memory just being the application code itself. We go from having effectively the human operating system, flipping switches, to VMs where we have a fully virtualized operating system for each entry, to a container where I just have my app and its libraries, it's all I need. So we're getting more and more abstractable, more and more automatable, and we're consuming less and less energy. So this is that evolution of process isolation I'm talking about. And I talk about it a lot to a lot of people. Because what that means is there's something further along to the right. Containers aren't the end game. There's some kid sitting at Butte County Community College or MIT or somewhere thinking up the thing after containers. And we have no idea what it is. We couldn't have fathomed containers till someone come up with them. We couldn't have fathomed VMs 25 years ago. Someone invented it. they're an evolutionary process. So there will be a more effective process isolation than containers at some point in the future. So if what you're focusing on is how to build a better container, it's what we talk, the biggest candle factory in the world didn't win the light bulb war. If you focus on one technology and don't know how to make your process fit the next one, you ultimately lose. You lose by design. So there's a thing coming after containers, so we can't focus on. So when I talk about containers are dead, I talk about containers are designed obsolescence. They're designed to be supplanted because they're an evolution. No clue what that evolution is going to be, but it's going to be something. Does that make sense to everybody? And so every time I walk into a customer site and they're talking about that, they're focused on how to build a container, please stop. Focus on building your app. Focus on your application. And then we can orchestrate, we can automate the container process. So much standards, such containers. The reason we can do that so easily with containers is that we already have a standard. There is a runtime spec. All containers are the same format. Unless you talk about Pivotal, but we're not going to talk about Pivotal. They do their own weird thing. Almost all container engines we're going to talk about today, all use the same container format. It's on GitHub, the soon-to-be Microsoft GitHub. Yeah, so I'm staying current, man. I'm staying current. It's literally that URL. You can go read what an OCI, an Open Container Initiative container, looks like. VMs still haven't gotten there. In 14, 18 years, whenever VMs came out, we did it in containers in less than 4 years. We standardized on a format. I still have OMIs and QCal2s and VMDKs and OVFs. And what's the Hyper-V format?
Who cares?
Yeah, exactly. Someone just said, who cares? Ouch. Like, I dogged Pivotal. You can't really dog Microsoft these days. Like, Pivotal, okay, I'll get away with it. Like, it's not like an Oracle joke, but yeah, everyone can hate Oracle. So we have a standard, which means I can write tools to consume that standard. I don't have to worry about building the container. I build the platform, and I let the platform build my containers whenever it needs to. All containers consume a common format, means a lot of the tools you can automate and create. We have off-the-shelf tooling that creates containers for us. So when a dev spends 6 hours of their workday figuring out how to write a hacked-up Docker file to build a container image, they've wasted 6 hours of their workday. They've not fulfilled mission for 6 hours. And then when they hand it to the ops guy and he can't take it into production because it's a super hacked up Docker file, you waste 6 hours of not fulfilling mission. Let the applications build it for you. Don't spend your days and nights figuring out how to build a single container. We've got tools for that. We've got tools like these. Builda and Podman and Scopio and Cryo. Cryo is actually a container runtime, but the logo looks the same, and I like to talk about Cryo. We have tools to do that. These are all open source tools. These are all open source processes that build containers, that manage container lifecycles for us. And they integrate with tools like Kubernetes and tools like OpenShift seamlessly. So that idea that I can just write my code and then I have a process that takes my code and puts it in a container in the proper way and deploys it to my platform, that's where we have to focus. That's the end goal of the day. Is everyone with that? I know it's after lunch and y'all are on cookie coma, but I'm gonna start asking random probing questions. Like what's your favorite walk on the beach kind of music kind of stuff? So we have tools like Builda. Amazingly, Builda is a little dig at one of our chief engineers. Red Hat made Builda. It's supposed to be Builder, but Dan Walsh, who a lot of you folks have met over the years, he comes down to DC a lot to talk about SE Linux, to talk about containers. He's got a super duper Boston accent. So when he says Builder, it sounds like Builda. So we have Builda. Builda builds containers. It can take a Docker file, but it can also just take your source code. There's a tool in here, I didn't stick the logo up here because it doesn't have a logo, but there's a tool out there called Source to Image that's integrated into our OpenShift product. I tell it my source code, I tell it what kind of app I want it to be, whether it's Tomcat or PHP or whatever, and it goes off. At the other end, I get a custom container image specific to my build, and it's just done. And yeah, it works really good for Hello World, and when you're trying to figure out how to do that for your crazy legacy Java app that takes 13 hours to start up every time you reboot the server, yeah, you may not get that into source to image in 3 hours. That might take a little time, but you can do it. Because all container formats are the same. It doesn't matter where I'm running them. I don't have to vert a container. They're all the same format. I don't have an Amazon container format. I don't have a Red Hat container format. I don't have, well, VMware doesn't make containers. I don't have a VMware container format. They're all the same. And these tools are the things that manage them. Scopio has actually been around a long time. The logo I'm not a giant fan of. It's a telescope wearing a hat. I don't know what's going on there, but it's a telescope wearing a hat. Well, we really need to ask the person. But Builda is a Boston Terrier. I mean, it's kind of fun. And then Podman is a pod of seals. Get it? Yeah. No, it's a pod of seals.
Looks like a Pokemon.
Oh, does it?
Yeah.
I don't do the Pokemon thing. Yeah. Cryo is a flip, an inverse of the Kubernetes logo. So Cryo, I'm going to plug here for a second because I think it's awesome and we actually have time. I didn't know how long these slides would take, so we actually have a couple spare minutes. When you talk about Docker, how many of your developers talk about they built a Docker or they built a Docker container? How many of y'all talk about you built a Docker container? Yeah, Dockers are Q-tips, right? They're all cotton swabs at the end of the day. So Docker is what they are. And I'm not going to insult, I'm not going to make a Docker joke because there's no need to make a Docker joke. But the container format that you build when you run docker build-t whatever is the same format that the Rocket container runtime runs, that CoreOS made, is the same container format that everything runs. Cryo is a container format that Red Hat came up with and actually contributed to Kubernetes. A little ugly inside baseball, the reason, if you use Kubernetes, the reason you have to use Docker version 1.13 is because anything beyond that hopelessly breaks Kubernetes. Because Docker sticks a bunch of stuff in there, and the Kubernetes team got tired of having to go in and figure out what they did to make changes to figure out how to unbreak Kubernetes. So they just locked in at 1.13 and said, we're not going past that. Cryo ships as part of the Kubernetes repository. It's in the Kubernetes code base. Kubernetes has its own container runtime that it comes with out of the box, and it works out of the box. And more importantly, every time someone makes a commit to the source code for Cryo, it goes through all 3,000 plus tests that every Kubernetes commit goes through. The Kubernetes integration system, like when someone makes a commit to the Kubernetes on GitHub, the testing rig that those people have built out is almost as impressive as Kubernetes itself. It's amazing. It runs, I think, 3,600 and some odd tests for every commit to make sure that it's functional. Cryo goes through every one of them. And it goes through 400 or 500 before it's ever actually pushed to Kubernetes. So Cryo's never going to break kube. And run Kates. Everyone know what K8S is? The shorthand for Kubernetes. You know, K, 8 letters S, because Kubernetes was hard to spell way back when. But we all speak Greek now. Fun trivia for the day, who knows what Kubernetes means? Helmsman or captain. It's Greek for helmsman. That's why the logo is a ship's wheel, because it steers the boat. It's kind of cool. It's fine. Everyone gets phone calls. My phone's buzzed 4 times since I started talking. So tools like that, these are the tools that we're using in the next generation. Also, another little fun fact, Cryo has no daemon. There's no daemon running. Yeah, thank you, Tarek. One of the biggest attack vectors of any application is a persistent daemon sitting there listening. Cryo has no daemon. There's no daemon listening. You don't need a daemon running persistently to create containers. and to manage them. So if not the container, if I don't focus on the container, what do I focus on? Right? What do I need to, when I'm having those discussions with my devs, when I'm having those discussions with my ops teams, if I'm not focusing on the container thing, because it's just an evolutionary step, it's not an end game, because there are things to build containers for me, I don't need to do that anymore. I mean, who writes the XML for a VMware VM anymore? That's what a Docker file is, y'all. You could go do that. Or who writes the XML for a KVM VM? You could go do that. We have tools to do it for us. We have tools to do the same thing for containers. Docker file is not required anymore. So if not the containers, then I focus on orchestrating my application. I focus on not how to build a container, but once I have my container built, how do I spread that container across 5, 10, 50 nodes and have it all work well together? How do I have it talk to the other services that it needs to talk to get its job done? Can actually stop and think about that instead of just being reactionary to it. When we dropped this new API in production. Well, what's it doing? Well, it's breaking the other API. We don't have to worry. We can think about what we're doing there in our orchestration. We can manage our application's lifecycle. I know they've talked about it a little bit up here this morning. The idea of an automated upgrade, like Clayton was talking about. The idea that I have a new container image because I have security updates. So I create a new container image with my new security updates, or I get one from my vendor that has the latest and greatest. That my application platform sees that and actually creates a new application deployment, runs through my continuous integration, continuous delivery testing rig, and builds and upgrades my application for me automatically based on the rules that I build for it. I start defining the rules that manage my lifecycle, not the rules of my Docker file. I get to start thinking about that. That's the stuff we have to have discussions around. That's the battle we're fighting these days. It's the battle we should be fighting. We get to take a new perspective on our application security. Containers give us the first time for a lot of really cool security technology to be practical. Probably the coolest one is SecComp, SecComp, and it's the next button. It's the next bullet. Oh, no, it's not. That's why I left it here. No one saw the red letters. But SecComp is built into the kernel. So a little fun trivia for the day. A 64-bit Linux kernel has plus or minus 850 kernel API calls. And a kernel API is a syscall into the kernel. So an application could do anything. Anything it needs from the kernel, it's requested through an API call. 850 plus or minus. I think there's 420, and then there's a 32-bit and a 64-bit version of each. So if I can actually, using SecComp, and it's really hard to say into a microphone because it's got that weird C in the middle, SecComp. But with SecComp, I can write a whitelist to only let my application use certain kernel calls. So I can make it not let it make any 32-bit system calls, and I just halved my attack surface of my application out of the box. The 64-bit app doesn't need to make 32-bit calls. And if it tries to make a 32-bit call, I kill it because it's doing something it shouldn't be doing. I can do that with containers practically and easily for the first time. Role-based access control, where the application is built and managed by system accounts, not by users SSHing into a server. That kind of security, really thinking about making sure my application running in my containers have the absolute least privilege they need to get their job done. That they don't have a bunch of permissions and a bunch of abilities and capabilities inside their server to do things that they don't really actually need to do. If an app doesn't need to open up a socket on a server, don't give it the ability to open up a socket. And we can think about that. Those are the discussions ops and dev needs to be having when we talk about transforming DevOps. That's the discussion we need to have. We don't need to be arguing about who gets to run a container as root and how to build a Docker file. Have a discussion about whitelisting API calls with my container, with my application. Your devs will go nuts. Your security team will love you because you can give them demonstrable proof that you just utterly slashed the attack surface of your application. That's winning. That's where we win. That's where these things are revolutionizing how we do our jobs. So focus on delivering the app, not on writing the Docker file. Focus on the app. Focus on the platform that delivers your app. That's the Kubernetes logo. It's the ship's wheel. We all speak Greek. That's the OpenShift logo. OpenShift is Red Hat's implementation of Kubernetes. We take Kubernetes, we add some stuff on top of it, we stick a couple Legos on top to give a little added functionality, and we ship it out the door. Two of the most popular open source projects going right now. Focus on this. Go learn this stuff. If you want to figure out how containers work, go read chapters 3 and 9 of OpenShift in action. I go all the way to the bottom of the kernel. We walk through every single namespace. We walk through, and this is kind of silly, kind of Linux geek math. When you tell a container that it's limited to how much RAM it can consume, we actually walk through the numbers in the kernel that you use to divide to figure out where the math comes from. We walk all the way down to the bottom of the kernel to get all that stuff done. Yes, you need to know that because it's going to not work right one day. But when you need to deliver your apps, focus at this level. Don't focus all the way down there. Focus on things like CI/CD and source to image. How many times have we said CI/CD up on the stage today? 10? Probably 200. Operate with absolute least privilege. And this is kind of the call to action slide, FYI. Continuous integration, continuous development, source to image, least privilege models, role-based access control. That's the stuff we need to be focusing on. Automating application upgrades. That's built into OpenShift. The ability to do it is built into Kubernetes and OpenShift. Make powerful security technologies like seccomp practical in your environment. There's actually a library that you can hook a container up to and figure out every API call it could ever make. And that's all it's allowed to make. So if it's making something beyond that, someone's got a hold of it that it shouldn't be doing. That's reality. We can do that today. I did it on a little Hello World PHP application. It made literally like 68 system calls out of 850. It was a really simple app, Chris. Chris Short was like, really? No, it literally made like 68 sys calls. Really simple little web app. So I needed 10% of what it had by default. The rest of it, I could block away from it. Figure out, then focus on, and this is, I talk about this as an old ops guy a lot. When I was an everyday admin, I wanted my pillow to be soft at night. I wanted to be able to sleep well with what I had built in my data center. So figure out what is keeping you up at night, and then focus on fixing it. And I would totally bet lunch. I'll bet lunch that everyone in this room, everything that's keeping them up at night about their applications, about fulfilling their mission, fits into those 4 points up there somewhere. It's security, it's automation, it's CI/CD, it's app delivery. Everyone's pain points are listed in those 4 bullet points. So figure out which ones are killing you and go focus on it, go fix that. And we're at 15 seconds left. So I guess my parting question is, how does that make you feel? Like, did I hit you over the head too much? Or, I just insulted everyone's container strategy. And I apologize for that, but I'm tired of having that conversation, so I wanted to have it en masse. So we're right at time.
Do you want to take any questions?
If we've got time for it, sure.
I'll spot you 3 minutes. That clock's a little bit fast. Anybody have any questions for Jamie?
Thoughts, questions, concerns? The young man in the front with the nice hair.
Jamie, your presentation. What do you say to organizations that have an existing container build strategy already in place, and how do you get them convinced that this is a better way to look at it at the abstract as opposed to reinventing something they invested in for a long period of time?
So the question was, I don't know if the mic was hot. It wasn't very hot if it was.
He didn't shove it in his face.
Oh, that's what it is. You got to sing like you're a rock star, like right up there.
Yep.
So the question was, if someone's already doing something with containers and it's kind of, and God, I hate to say this, but if it's a legacy container platform, Jesus Christ. Jesus Christ.
How is that possible?
Yeah, I know, it's possible. If someone has taken a bad swing, and we need to, and the ball's coming back at them, man, Like, they're hard conversations. I had a 2.5-hour lunch with a customer yesterday who's facing that exact problem. And the biggest pain is they think they're doing it right. That they think focusing on that, they think that the developers think they need to be root inside the container. And it's a tough, you just have to go and combat them with facts. And that's the only way, and you got to come at them, kind of harsh from love, but you just have to hold your ground. And the stuff that I set up here today, and yeah, it was very high level, but it's all backed up with facts and reason and in a world that's reality. All of those things are possible today. It's not possible when when developers are pulling stuff off Docker Hub full of Russian rootkits. And you just sometimes you got to scare them, sometimes you got to love them to death, sometimes you have to beat them over the head with it for 2 years. But you have to do it. It has to happen, or it's just gonna fail spectacularly.
One more question. Anyone else?
Anything else? Or you all just want to go see if there are any cookies left? You're going to go see if there are cookies
question way in the back. Uh-oh.
Oh, wait. Make them earn it. Make them earn it.
Jamie, that wasn't nice. We're going swimming or running or biking later. Your choice.
I'll be sitting on the airplane in my first class upgrade.
You mentioned about where things have to go the next step that we don't know where it's going. What type of technology are people looking at right now to go to that next step? Or do you have any idea?
I honest to God don't know. Some people say serverless, but serverless is just a way to present a container. And so serverless is just part of the container evolutionary step. What's next? I don't know. Chris, I'm literally polling the room. I can't fathom a more efficient way to isolate a process than a modern Linux container, but I know there is one. Maybe we all turn around and start looking at unikernels again. I don't know. But whatever it is, I know it's coming, and I know I want to set my customers up to be ready to consume it. That's always be ready for change, and always have an exit strategy for your current thing, is what I try to tell people when they're in that scenario. We did it as an industry. We did it really poorly with VMs. I don't want to see us make the same mistake twice.
You replicated the hardware
Yeah.
in the VM.
Yeah, and we can't do it again with containers. And when bad implementations happen, they're thinking of containers as VMs. It's almost 100% true.
Awesome. So Jamie, with that closing thought, I'm sure that answers the question in the back. Thank you again, Jamie.
Yeah, no worries. Thanks,
Everybody.
folks. Thanks, folks.